Hi there, I'm Zhenpeng from Urban. Today, I'm talking about my internship work with Groundwork Data, a research firm that develops smart energy transition strategies. I was helping them digitize the Massachusetts gas system and support decision-making about when and how to make changes to the gas system. Let's start with the problem of the aging gas infrastructure here in Massachusetts. It has been more than 100 years since the first gas pipe was buried underground. The system is still functioning today, with a lot of pipes becoming aging. An example here is the gas pipe within BU Charles River campus. It is 12 inches in diameter, made of cast iron, and has been over 130 years old. It seems necessary to completely replace all aging pipes. However, the cost will be so high. People are actively thinking of an alternative solution called energy transition, meaning we're not replacing, but retiring the gas and use electricity instead to power our community. But the decision about closing any part of the current gas system could impact the function of other parts. That's why groundwork data would use hydraulic modeling to tell if we could remove any single pipe while keeping the system in good health. The model simulates how gas flows in the pipes from sources to end users and reports the pressure of any point to foresee the impact of the interventions. To make the model run correctly, my job was to create digital maps that are readable to the model and contains all digital objects of the gas system, including main pipes, service lines, and connection nodes. Beyond this, within the 15 weeks, I helped create a standard workflow repeatable in any Massachusetts towns with GIS software. The workflow processes those layers with a specific order and could handle potential problems like duplicate records and wrong locations. Following the workflow, one could digitize the local gas system in any town with minimal manual input, saving your time and resources. Coupling the digital gas system and the hydraulic model, we can simulate the impacts of changes to the gas system. Let's see it in action. We can do some experiments like this. In a functioning network, all homes have adequate pressure. But if we propose the energy transition plan by closing the service to the community on the bottom part, a lot of homes that should not be influenced would also end up with insufficient pressure. This means that ill-planned interventions, even being so small, would bring problems. Therefore, digitization helps utilities anticipate risks before they escalate. In closing, digitizing a gas system isn't just about pipes. It's about enabling a managed transition to a cleaner energy by knowing the vulnerabilities. Special thanks to Michael Walsh at Groundwork Data for providing guidance about my internship, and Emily, Pam, and Ranga at BU for their support. Thank you.